Okay, we are beginning a short demonstration of the Oliver Massachusetts GIS online mapping tool. And I use Oliver because it allows me to accomplish a whole bunch of different things all at once in a single GIS. And first of all, what I'm going to do is I'm going to orient you to this particular GIS, and then for this water resources or geography of water class, what we're actually going to do is we're going to do a few tasks that are related to the basics of the watershed, basin, river, all of those kinds of items that we've been discussing. And you are, of course, quite welcome to explore the GIS in any way that you want to. And I'm going to try to do this relatively slowly because there's a lot going on here. But I'm not actually asking you to become experts in GIS. I'm only asking you to do some limited tasks. Let's get cracking. Some of these functions will be things that you're perfectly familiar with from your own work in Google Maps or Waze or any of the other mapping applications. But here we're in a GIS, so we're going to be talking about spatial data, attribute data, and the way in which they can be blended on a single map. We're not doing a ton here. And some of you might get a little nervous about this, but just follow along and pause the video, jump out, or just press another tab in your browser to get into Oliver and try the things that we're trying. Some of these things I'm doing on the fly, so if it gets a little bumpy, you'll know why. Right, let's get cracking. First of all, what I'm going to do here is, in the browser that I'm using, I think I'm using Chrome. Yes, I am. I'm going to press F11, and this is on a PC, and what that does is it gets rid of the tabs and menu. If I press it back, you'll see that those will reappear. It's sort of entering full screen, and what that does is it gives us a bit more screen real estate to use. Now for some basic commands. You'll see this blue thing right here. Well, that's a zoom bar, and so if we zoom in, and I'm on my home internet, so it's a little slower. If we zoom in or we zoom out, you'll see that the map actually will change its display. And sometimes that is just zooming in and out, but other times it actually changes what's actually shown on the map. And so you, without knowing where you are here, in terms of place names, you can see that what this map is rendering at the moment is some contours, right? So you can see the numbers on the contours here, and so they're showing elevation. You see 984 right there, and you know that the tighter the contours are, the steeper the hill. So there it's quite steep. Here it's not so steep. We got some wetlands. That's the standard symbol on a topographic map for wetlands. And notice up here that when I move the cursor off the map and into this bar, this icon bar, what it does is it tells you what different things do. So we're using the pan tool at the minute, which means that we can move around on the map. But and this is on a PC, if you hold down the left mouse button or the left button on your tracker, you can pan. See that? You can pan north, south, east, west, and you're cooking with gas. You can also pan just using these, so you can pan a given amount using these little arrows. And supposing we want to get back out to the widest map that this particular GIS has, well, we can actually press this, which is what's called the zoom to initial extent or full extent button. Everybody got it? Zoom in, zoom out, zoom to a scale in some custom base map. We don't need to worry about that. The pan tool, zoom to initial extent. Sometimes that's called zoom to full extent. This says zoom to full extent of your active data layers. We don't need to worry about that for the minute, but that might be important if you have a particular data layer that's active and you need to look something up. This says go back to previous extent. And so if we click on that, it's going to zoom us back into where we were. And then this says go to the next extent. And so that takes us to where we were in terms of zooming. And so zooming, the scale of the map is called an extent. And what we got here is, obviously, for those of you who are from New England, and for those of you who can recognize New England, this is a map of Massachusetts. And so here's Vermont, here's New Hampshire, New York, Connecticut, Rhode Island. This is Long Island. You can see the Cape, you got Nantucket. You get the idea. And what this map is showing at its full extent is it's got some green on it, which I presume is showing some kind of forest. And it's also got rivers. We can see this pretty significant reservoir or lake here. We've got another lake here. We've got some other lakes here. And sometimes it's interesting just to zoom in on those and check out whether they are natural lakes or reservoirs. And we may actually look at some of those in a minute. You can see a big river here. You can see, this is the Boston area, so you can see a river here, the Charles River. You just get the idea. And then here we have clear location search results from the map. Because if we put a location in here, let's just try putting the Quabbin in. It might not get it. Quabbin, Massachusetts. I'm going to say yes. And it's going to zoom right in and put a little spot on that says the Quabbin. And it's zoomed in a lot, hasn't it? So if we zoom out a little bit, and my internet is a little slow, but Quabbin, the location Massachusetts, Quabbin, Massachusetts, is here. And I'm actually going to clear that. And so it clears it off the map. But take a look at this beastie. And this is a pretty serious lake. It's a pretty serious lake. And so this is to get to a location. So for example, if we put Worcester and press return, it's going to say, yeah, do you want Worcester, Massachusetts? And we're going to say zoom to the region. It's going to put a box around, and this is the Worcester region. Make sense to everybody? Yeah, it's kind of cool. You got it. Well, let's clear that off. And you can, on this map, also zoom to a town. And so if you click on the drop down, it will give you the towns. And I think if you put the first couple letters, oh, that's not working. But you can drag down to a particular town. And so I'm going to drag down, I'm going to pick the town where I know that my mother-in-law used to spend the summer, which is Princeton, Massachusetts. And that will take us to Princeton. We have some information here. This says, identify features by clicking a point or drawing a box. So we can click on that and we can just try and see what information it gives us. And it's not giving us information because right now all we have on the map is a baseline. We can clear that. We're in Princeton, but we could just get right back out to full extent. Moving across quickly, we'll do this circuit relatively quickly. You can add data layers from outside. We're not going to do that. You can also make the link to where you are in the map permanent. And so you can make a link, send it to yourself, and it will take you back here. You can also print the map, and there are some things about printing the map that are a little specific to this particular GIS. But you can also print it using your print function, or you can screen grab it. This also says you can launch the data export wizard, which means that you might want to export some data to use in another GIS, and then it should have a help And if we click on the drop down, it's like, do you want help in HTML? Do you want it in a PDF? We won't be using a lot of help. Let's keep going. Let's keep going. We're going to go down to the bottom here, and you'll notice along the bottom there are some things as well. So let's take it left to right. This is the measure by length or area tool, and if we click on the drop down, or actually it drops up, it's going to give us a choice to measure by length, to measure by area, to choose the units that we want. Right now it's set for miles, and so you notice the cursor changed to a cross. And so if we wanted to just measure, it's a blunt instrument here, from the border between New York, Vermont, and Massachusetts, right there, to the Connecticut River, right there, we press click. That says it's 40.53 miles. If we double click, it puts it in the box right there. Make sense? And if we cleared this and we chose the area, we could, I'm just going to do a blunt instrument, we could go from the same point to the Connecticut Valley, down to the Connecticut border, Connecticut River Valley, down to the Connecticut border, over to the corner of the New York border. I'm going to double click, and it's calculated the area of that polygon. Ooh, a polygon. So what we've done then is we've used this measure tool in a number of different ways. I'm going to click off that. There's one more thing that this allows us to do. It's kind of cool. It's a buffer tool. And if we click on the drop down, which is actually a drop up, but hey, life goes on, and we choose the miles, we can choose yards, feet, nautical miles, kilometers, and then if we choose let's make it a 10-mile buffer, and then we go on the map and we click a point, it creates an area which is a circle that buffers around that point we chose. And any point we put in, it will buffer for us. Does that make sense to everybody? I certainly hope so. And again, we can just clear that. We're still in the measure tool though, and so we want to click here to get to the pan tool, and now we can pan around. How's that? Oh, we got some more on the bottom. Here, it says show or hide coordinates and the scale bar. And so if we click down, which is a click up, it says show coordinates, show scale bar, show scale ratio. And those are all checked. So we do have coordinates here. And you can see that these coordinates are numbers that are being represented in meters. And that's because we're using, and you don't need to get into this too much, but we're using a particular projection, and the grid is on that projection in meters. So these are not latitude and longitude coordinates. However, we can choose to put them on in degrees, minutes, and seconds, and so that will tell us exactly the coordinates. We can also put them on in decimal degrees. And you don't need to know this for this class, but those are just differences in representing the coordinates of particular points. And as you move the cursor around, of course, what's happening is the coordinate is changing. So we're almost done with the base orientation. We've got one more thing to look at, and that is a selection of base maps. And what we have here is we have the Massachusetts GIS statewide base map. And we're good to go on that. And that's lying on the map. What we can do is we can actually adjust the opacity or transparency of the base map. You can see if we make the opacity 0, it means you're looking straight through it to nothing. If we make it 100%, it means it's opaque and we cannot see through it to any other layers. Because it's the base map though, it's the bottom layer. And so any layers that we put on will be put on top. What else do we have? Well, we could choose the Google terrain map. So if we put that in, we check that as the base map, you'll see that we've got a different map. And now we've got a bunch of labels. And this is actually the Google Maps terrain map. And we can zoom in and you can see that, oh, this is nice. Because we get to look at some things that help us figure out exactly where we are. So that's kind of nice. But it's also a map that is going to clutter things with route numbers and everything else. So we could put the Google Road Map on, which is the same map that's used in Google Maps. And if you're familiar with that, you might be happier with that. We can also put on a Google Hybrid, which is a superimposition of geographical information on the base satellite image, of a product from Google. We can also use OpenStreetMap, which some of you may have used, and this is used in a lot of what's called crowdsourced information. And you can see now, a clue that that big lake that we looked at is actually the Quabbin Reservoir. And so we know that that's actually what was going on there. And remember, I zoomed to a town, Princeton. Let's go back there. And when we're in Princeton, which is right here, you can see that in OpenStreetMap, we get a bunch of things. Here's a conservation area. We've got a little airport. We've got a wildlife management area. We've got the Leominster Town Forest. And this is the East-West Main Road Route 2, which some of you may know. So that's the OpenStreetMap base map. And we can also get some ortho images. And what these are their satellite images. Sometimes they're air photos, but they're satellite images. And these are, let's just go back here and look. These are from 2013 to 2014. We can also get the Google ortho imagery, and we can put that on. It's a little bit different. And so the imagery for the base map, whether it's a map, a satellite photo, and so on. And you can see that what this is doing is tiling in. And I don't know if you can see this on your screen, but can you see how this has stripes? And that's because these are compilations of almost like a reel of raster data, like a film reel that have been compiled together for coverage. I'm going to go back to the Massachusetts base layer, which we started with, and that's your basic orientation. Let's go around the horn again. Zoom in and out, pan, zoom in, zoom out. Don't need to know that one. Click on the pan tool, zoom to initial extent, zoom to full extent of active data layers. We might use that in a minute. Go back to your previous extent, go to the next extent, search for a location, clear the location, information, which we'll use in a few minutes, zoom to a town, add some data from outside, make a permalink, do some printing or saving, launch the data export wizard, get help. Along the bottom, measure, clear the measurement, put a buffer on, show coordinates or scale bar, we can just switch those off. Boom. That's 1. Sorry, we have to do it separately. That's 2. That's 3. We can put them back on, show coordinates, show the scale bar, show ratio. That's right there. This is some choices over how we show the coordinates. Base map choices, we're good. And remember that you can, oops, let me switch that off, that you can speed me up in the video if you are like, I got this. And let me make a note, and I'll try to put this in the instructions. If you're familiar with this kind of thing, we want you to be able to skip forward. So let me just get a timestamp on this. Okay, so we've done the baseline discussion. Now we're going to talk about layers. And where we're going to be working on layers is in this right-hand panel. And I just want to show you a very quick trick that if you don't want to look at the layers and you just want to be looking at the map, you can make the panel disappear by just clicking on those two little doohickeys right there. And it's all about screen real estate. It's all about screen real estate. Right, let's get cracking with some layers. I'm going to zoom this out to initial extent or full extent. It's the same thing. And what I'm going to do is I'm actually going to give you a quick tour of some of the layers that we will use and you will use. And you can look at any of these that you like. Any. And so it's just a file folder system. And just to be clear, if you click on the plus, it's going to open. It might have another folder you can open, and then you can just collapse it. And so it's just a folder system like you might see on any computer interface. But what I'm going to do, let me just collapse it so you would see how you will see it, is I'm going to focus on physical resources for a little bit. There are a bunch of things on here, so you can poke around as much as you like, but don't do too much. Don't do too much because you'll find yourself using too much time. Remember also that you can pause me in the video and play around for a little bit if you want to. Right, physical resources. We got a bunch of them. Anadromous fish, aquifers, ecoregions, names, hydrography, water features, prime forest land, topography. Just collapse that for a minute because we'll go. I'm actually going to look for watersheds initially. And this is how you will see it when you start. And what we're going to do here is we're going to click on watersheds, and we're going to, if this appeared like this to you, we would click on the plus and we would get major basin outlines. And so I'm going to click on that. And that's a layer. As opposed to a folder, that's a layer. So I clicked on it and look what happened. It appeared on the map, but it also appeared in this active data layer window. Do you see that? That sort of sub window. And so we can see it in here, and it also appeared down here on the legend window. So it's saying, hey, anything that's got this purple line around it is a major basin. And we could move that up a little bit, or we could move that down a little bit. And you just drag that to get different levels of visibility. Perfect. Now this is a layer, and so in a GIS, we can switch a layer on, we can switch a layer off. And what you'll notice here that with the major basins, the basins all end at the Massachusetts boundary. Do you notice that? And that's kind of interesting in and of itself. But what we're also going to do is we're going to put on the map major watersheds. And what happens there is the watersheds do not stop at the state line. So I'm actually going to uncheck the major basins. And here are the major watersheds for the state of Massachusetts. And I'm just going to try this. I'm going to go into the Quab and just put myself right in there. And I'm going to, I clicked on this information button, and I'm going to click inside of that. And it's telling me that this is a major watershed layer. It's just telling me what's active. And if I click on here, it asks me to identify a feature by putting a polygon in. And so I'm just going to draw a polygon really briefly. And it's going to say this is the major watersheds layer. Boom. That's what we got. And if we click on the layer, it's actually going to tell us inside what the watershed that we're in is. Let's try that again. Click on information. We're going to go right in here. It's going to say major watersheds. We're going to click on the line, and it's going to get the features. It's going to say, oh, that's the Chicopee watershed. It's this many square miles, it's this many acres, and its nickname or tile name is this. It's like, okay, well, what if I wanted to look at all of the watersheds? I could click zoom to all, and with just a twist of luck, it's going to zoom the map out. See how it did that? It zoomed the map out, and it's highlighted the one we're in. And if I go over here, it might not do it in quick order. I might have to do it one by one. But we were now in this other watershed, and that's the Deerfield River, or Deerfield watershed. And you get the idea. So we have an ability to get, listen to this carefully, the attribute information from the map. I just quickly zoomed to full extent. See, I did that? I've still got this tool active, so I want to go back to the pan tool because I don't want to be clicking and getting information. So we're good to go on that. Now, let's look at the NRCS HUCs. And you will have already looked at these in your existing research, but let's put on the HUC 8 hydrological unit classifications, and now they're on the map. And what they're doing is they're putting the HUC 8s that are connected with Massachusetts. And so if we switch off the major watersheds, take a look. Now, these HUC 8 watersheds, well, this one goes way off into New York. We got this going up into Vermont. We got a tiddler right here in New Hampshire. And take a look again. If we click on major watersheds, right, they cover up some of these because they're at a higher level. They're at a higher level of generalization. And so what we're really doing here is we're looking at different levels of resolution. And when we zoom in, what we're actually doing spatially is we're disaggregating the image, but we're also disaggregating the watersheds. So let's put on HUC 10, right? And let's put on HUC 12. It's got to load. My machine is slow. And so you'll see that what we've got is a whole bunch of new watersheds. And if we switch off 8 and we switch off 12, we get the 10s. Here are the 12s, here are the 8s. And so if we switch off those two, you'll see that the more digits, the smaller the area. See that? That's a 10 digit, that's a 12 digit. And I asked you to look at, in your previous work on the USGS site, and you explored that. So we don't know what you explored here, but I did ask you to make sure that you understood the HUC, the HUC, Hydrological Unit Classification System. And here we're actually seeing it mapped out. Now we've got one more. We've got sub-basins here in a folder. Let's click on that and see what that does. Oh, wow. And so what's happened there is we're looking at an even finer level of resolution. And I think it's time to zoom in rather than look at this level of generalization. And if you have a wheelie mouse, that's what I call it, a mouse with a scroller in it, you can actually use it to zoom in. And I have one, but for some reason it's not working on this particular day. So let's just take a look, not at that general level where we were looking really broadly, but let's zoom in a little bit tighter so we can actually see how these polygons actually appear and disappear. So let's switch that layer off. We've got the base map, and let's go with the HUC 8. And we can't see anything because we're zoomed in too far to see the boundary. Let's try HUC 10. There's a HUC 10 boundary, right? And if we zoom out just a little bit, let's just see if we can get in our view a polygon that's a Huck 10. Yeah, we can do it. Let's just pan this up a little bit. Or we'll go this way a little bit. We're almost, yeah, that'll do us. That'll do us right there. So we got a Huck 10, and you'll see there was a gap here because it's redrawing, and I'm on a slow internet connection. So if you're on a high-speed system, you'll see these will redraw relatively quickly. So we got a Huck 10. Now let's look at a Huck 12. And what do you notice? Well, if we switch off the Huck 8, you'll notice that what the Huck 12 does is it breaks up the Huck 10 into even finer basins. Can you see that? And so here's this basin, this Huck 10 watershed, right? And then if we click on this, you can see it breaks it up. Everybody got that idea? That'd be cool if you can gather that idea. That'd be absolutely cool. And those are called nested hierarchies. And I think I might have mentioned that before. Let's put the 12s on and take the 10s off. And let's just focus in on here, right here. And we're going to put the subbasins on. It's going to take a while to load. And so what you can see in Massachusetts is that the state has data. The state has data that is the disaggregation of the Huck 12 USGS classifications. Now that in and of itself is kind of cool, and you might say not to me, but I'm just telling you it's kind of cool. Now we could change the base map and examine these, but I'm not gonna have us do that. I want to put some contours on, and because we've got contours on this map, but I want to put some contours, and I'm going to put the 30-foot lines on, and I'm also going to put the 3-meter lines on. And those are both going to come on, and you'll notice that there's a little yellow exclamation point. What it's saying is it's not available at this visual scale. And I'm actually going to switch off the hydrological features, and I'm not sure if it lets us zoom here. It does. So what we can do here is if we right click on it and we say zoom to layer, it will take us to a layer where those contours are visible. And I'm not really sure why it took us to that scale. It might be something that we're not happy about. But I'm going to zoom in, and I'm just going to step in, and I want to see when those contours become visible. And we want those 30-foot lines to appear. And the smaller the number on the lines, the bigger the larger the amount of data, and therefore the closer in you have to get them. And so right now we're seeing those. Let's keep going. And I think we're starting to see the 30-foot lines. Right? We're starting to see the 30-foot lines. You see these yellow ones, and we know they're yellow. So we've got the default topographical lines. Let's switch the 3-meter lines on, switch those off, and you'll see that the 3-meter lines, let's zoom in all the way in. We're seeing right now contours that are at 15-foot intervals. And if we zoom in all the way, let's have a look. We can see that they're following the base map lines, and these are at 15-meter intervals. Now, why do I want you to think about contours? What's a scoop there? What's a scoop in thinking about contours? Well, what I want to do is I want to put the subbasin outlines on So you can see how, if you're looking, this is a hill. If you're looking at the basin contour, what it's saying is, if a drop of water fell here, it would fall this way. It would run off this way. And if a drop of water fell here, it would run off this way. Right? And so the way in which contour lines show us the lay of the land tells us the way in which watersheds are actually, and subbasins are actually defined. And so if we put a Huck 8 on this instead of the we won't see Huck 8, a 12. Let's switch off the Huck 8. And we just zoom out a little bit. Come on. We should be able to see. The map is kind of busy with this base map. But there, just missed it. There we go. And so we should be able to see where those contour lines are visible for the Huck 12 watershed, right? And so that means that if a raindrop falls on this side, it's going to go into this river system or these lakes. Part of it is going to go in here. It's going to come all the way down here, and so on. And so what we're looking at here is we're looking at a way of figuring out the lay of the land using a combination of watershed boundaries. Let's put the subbasins on because they're the finest scale of using watershed boundaries and contours to really get a view as to what's going on. And I switched the 3-meter lines back on. They should show up in a minute. There they are. And it's sometimes hard to interpret this on a screen. And what the computer does is it figures out the watersheds based on changes in elevation. And so it sort of follows the lay of the land, and then it switches to the next basin when it gets to the highest value, and then it starts to go lower. Cool, no? And just so that we can be clear, when the land is steepest, the contours are very close together. And if we go for a, let's just go to an ortho, which is basically a satellite view, it's just called ortho imagery, you'll see that the contours and basin lines will actually show up, right? And so they're the 3-meter lines, and there's the sub-basins. So that makes sense to everybody. And if it gets too visually busy, you just switch off the layer. So now we're looking at the landscape from satellite, and these sub-basin layers. Does that make sense to everybody? I hope so. I hope so. I want to do one other thing, and then I'm almost done. Let's just switch back to the GIS layer, the base layer, which is a map that I like, by the way. But I want to, let's just collapse the contours, and I want to look at, where are we? Hydrography features, and I want to look at rivers and streams from the USGS, and I also want to look at major streams and major ponds, and I've switched those all on, and I think what we'll do is, well, let's switch off the subbasins, and actually let's switch off the USGS layer, and let's just look at major ponds. And so what you can see here, see how they're sort of bright blue? I'll zoom in a little bit. My wheelie mouse isn't working, so that's kind of frustrating. What you can see here is that these very bright blue polygons are mapping major ponds. But if we switch them off, you'll see that they don't map the pond perfectly. And so one of the things about GIS is you have to be a little bit careful in terms of what you're actually seeing and how detailed the land is, right? And you'll notice that, see this pond? That's not in that layer. which must mean that it's not classified as a major pond. Same deal here. Let's zoom in a little bit more. And I hope you're following along. I hope so. Same deal here. If I switch off major streams, you see there's clearly a stream that connects these two ponds. You see that? You see there's clearly a stream, and so that stream is flowing down here. And you know, we could figure out by using the contours. We won't do it in this GIS, but we could figure out how steep is that valley. But if we put the major streams layer on, we'll see that actually it's not following the stream that well. And so sometimes GIS layers and map layers don't line up perfectly. So one other thing about this, and I wanted to switch the major ponds off. Do you see how straight that is? See how straight that line is? And so when I see a straight line like that, I'm like, hey, is that a dam? And so I would, if I were looking, I would zoom in, right? I would zoom in and we'll figure out where the outflow was right there. If we switch on major streams, you'll see the major streams line is all over the place. And you'll see that it's digitized on a very general scale. We can talk about that in class if people have questions, but I'm zooming in all the way. Oops, the map is still displaying, but what I want to display is, I'm just going to go with the Google Ortho imagery and see what we can pick up on that and see if we can see, sorry my computer's slow, but see if we can see if there's a dam. And lo and behold, take a look right there. All the way down, what do you see? You see something. Not quite sure what we're seeing there. I'm not sure. I'm doing this on the fly. I'm doing this on the fly, and I'm using up a lot of time here. But what we're seeing here, I think that's an earthen dam. I'm not absolutely positive. It could just be it's got trees, so it could just be like a railway embankment or something. Let's just put major ponds back on, make sure we're in the right place. And this could be a feature of the way it was digitized. In any event, let's zoom to previous extent and just zoom out a little bit. Right, so we can see here now, and remember you can switch the layers on and off so you can see how the digitizing has actually been done. And I'm just being honest with you, I don't know what actually is going on here. It might be an old dam, who knows? We might be able to figure it out. Let's go to the terrain map, and we can see that that's called Lee Pond. And I'm guessing that this really is something that was created by a dam here. That's my guess. And sometimes when you see the straight line shorelines, it's often the fact that it's been created by a dam. Okay, we've got to do one other thing. Let's go back to the MassGIS base layer. And in the major, let's see, there's something else. We've got a wetlands inventory here, and so we've got the streams that have been documented by the National Wetlands Inventory. If I right click on that and I say zoom to layer, it zooms out all the way. There's something fishy about that particular thing, and it may load it and there'll be just tons of lines. Yeah, so what it's showing is areas where the layers are actually available. And I'm just going to go back to Princeton. You'll see I'm like messing you about here. I'm going to go back to Princeton, and we're just going to look at where those streams are, and it should render them, I'm hoping. Let's just see if it makes any difference. Yeah, so they're on there. And these are streams that aren't showing on the base map. Does that make sense to everybody? So if I try to get on one of these, it's going to show us this National wetlands inventory streams. And if I click on it, it's going to say that that's PF01 and it's got a global ID. I don't really get a bunch of information from that. So, is there anything else I wanted to show you? Oh, just so that we're clear, we can get land use. And so we can get land use from 2005. So it's slightly old, but I want to show you what happens here, and I want to just point out what we're actually seeing. Do you see how it says land use 2005, and do you see all these categories? Well, what kind of data would that be? What kind of data would that be? And I'm just going to pause for just a second. Notice that what it's doing is it's describing something that is a kind of something. So forest, open land, water, wetland, saltwater wetland, cranberry bog. These are nominal data. These are nominal data. And you'll see the map gets, whoops, I'm still in information. That's a rookie mistake. I need to be back to the pan tool. Watch out for that. You'll see that this map gets incredibly busy, and you have to be able to read the legend, and it will take, a little bit of time to render, but you get a sense of what all is going on. And we've got residential, we've got transportation, we've got mining, we've got junkyards, and so we've got a lot of information here. And what we're going to do, we're at a kind of middle level of zooming. So let's zoom in on this. It takes a minute to, a few seconds to redraw on my screen. But if we zoom in a little bit, and it'll redraw. That's called refreshing. If we zoom in a little bit, we should be able to get the land use of these areas, and it will take a minute or two to draw. So let me switch off the streams, because the more layers you have, the longer it takes to draw. And so you can see when we zoom in really close, let's just check this out, right? Let's just check this out so you can see what I'm doing. You see right here, we've got this polygon. See how straight the areas are? So it's like, what's that? Well, to know, we'd have to go down in here and look at what all we're seeing. And it's kind of grey, dotted. It looks to me like that is a non-forested wetland, right? It looks to me like it's a non-forested wetland. And if I right-click on the layer, I can actually slide it and make the layer. That is too bad, because what's not happening there, I don't know if I've got something else on, but what should happen in the GIS is when we zoom it out, when we adjust the opacity, we should be able to see the base map there. Let's just zoom it out a couple clicks. So the base map actually doesn't render very, very close in. You can only look at GIS layers. So let's zoom it back out. And now let's adjust the opacity. And you can see that that wetland right there is showing on the land use map from 2005. Does that make sense to everybody? That's kind of cool. And we could try and see if there's any information, attribute data on that wetland. Click on the information tool and then click on it. It's going to say that's land use. It's telling us it's found one feature. If we click on this, it should tell us what it is. And it may just say wetland. Yeah, and it says non-forested wetland, and it's got a land use code of 4. Sometimes you get some labels there. It's a little iffy and spotty. But if we go now on the base map and we put on the Google Terrain map, which should show at this scale, right? It should show at this scale. And our wetland is right there. So what's happened here is, because we have that base map, it's adjusted the zoom. And let's switch off the layer, the land use layer. We can still see that, well, I can't remember which our wetland was, right here. So if we switch off the layer, we were right in here. Anyway, what we're looking at here, and we've got, it's interesting, we're in the Fall Brook Reservoir, and we got a road there. There's a brook that connects this reservoir with this lake, and if we go up here, you see how it comes out of this higher area? So this is coming in, and we got another reservoir here, and I'm not sure. We could figure it out which way this is all flowing. But if we go to, and I think this might be where I end it, because now I'm getting drawn in. If we go to the ortho data for this particular area, ortho, the satellite imagery, they're called ortho data, and we sort of zoom in, we lose the blue of the water, right? So it's like, that's too bad. We can't see where the water is. But if we're careful, we could switch on major ponds so we get the blue shows up, so we can really draw our eye here. We can see that there's a major pond, but this reservoir is not in the database as a major pond. Let's put on some streams. Those are the wetland streams. Let's switch those off. Where are rivers? Put these rivers on. And you can see that rivers and streams gives us an outflow right here. And I think that's where we're looking at the dam. Let's take a look. Seriously, come on. Right there. We're looking right here, and this is clearly the dam. This is clearly the dam. So what we end up doing is, we end up doing sort of air photo interpretation, interpretations of layers. Let's uncheck everything, so we're just on a base map. Let's just go back to the GIS base map. And we're zoomed in too close, I think, for that base map to show. Let's zoom it out a little bit so we get it back. There it is. And then one last thing, and I think this will be the last thing, I want to check on infrastructure. I just want to see if there's a dams layer, and guess what? There is a dams layer, and we've got dams by hazard code, and there's a dam, right? And we might be able to put dams on with labels. It's going to tell us what the dam is, and so you can see this is the Fall Brook Reservoir and Dam. And let's just be clear about this. If we wanted to know about it, right? If we wanted to know about it, let's just put our cursor on this layer. So it's what's called the active layer. Let's go info, and let's click on the information. We've got two layers there because we've got the hazard code with the label and just the hazard code. If we click on that, it should tell us the dam. There's a national dam ID. There's the regulatory authority, and I've just made it full screen. Who owns it? The municipality. It's owned by the city of Leominster. Its latitude and longitude are here. It's been verified. It's got a name, and it's a high hazard dam. Now, I don't know what high hazard means, but it's telling us a bunch of things about that dam. Now, one last thing on this. What would you call this data? Well, this is not spatial data. This is attribute data. That makes sense to everybody? I hope so. And so I'm going to click off dams. Actually, you know what? Let's keep dams on, and let's just go to full extent and see how many dams there are in Massachusetts. And oh dear, it's not showing the dams. it says it's got to be zoomed in a little bit. So let's zoom in and see if the dams will pop up. It says they will show at the scale. Oh, I did not want that, sorry. I'm still on information, not pan. Sloppy GIS work. So let's zoom in and see if we can get the dams. And we only need one of those on, because one has labels, one doesn't. And it's not there yet. You can see that the scale is 1 to, it might be too small on your screen, 578,000. It needs to be a finer scale. Okay, so we're at 1 to 289. Zoom in, it should show up. It should be showing now. It should show. Let's have a look. And sometimes when you do GIS work, particularly in the cloud, you don't really know what you're doing. It's telling us to zoom all the way out for the layer, and I think something's fishy about that. I said it earlier. I don't think that's what we want. I do not think that is what we want. I think we need to go in closer, not further away. And if we zoom in to a place where there clearly is a dam, like here, rather than looking more generally, let's keep an eye on that. This is, I think this, I'll make this my last comment. I've got to wait. And so we see here that how many dams are there in this area? Well, there are a lot of dams. And some of these are going to be quite small dams. So when we think about counting dams, we're thinking about very, very different ways of thinking about dams. Some of those dams can be quite small. There's one here that's called Storage Pond Dam. Storage Pond Dam. Here the reservoir has a dike, because this is dikes and dams. Let me zoom in a little bit. Let's just put the other layer on, because what we've got here is, and I didn't point this out, you can see here that in the legend it's got a hazard code, high hazard, significant hazard, low hazard. And so you can see that the hazards are color coded into the map. And that's another way that a GIS would work. And I might try, I'm going to look at what's called the metadata for that layer. And what it's going to do, if we're lucky, is it's going to tell us where this data comes from. And so it's going to tell us the data layer contains points derived from a dam safety database. Most of the location information has been, from historic information, has been ground truthed. It tells us a little bit about what's going on. It tells us the attributes. See here it says the attribute table has this information. It has the other variables. And I was looking to see if it's going to tell us what the hazards are. And that must be just somewhere else. That must just be somewhere else. I wanted to know what high hazard meant. But this is what's called metadata. And what the metadata does is it takes us, whoa, I might be done in here. Oh, I know what we need to do. We need to get out of full screen and it's open the metadata in a new tab and just close it and we're back to the map. Right, so let's review. What have we done? We've gotten into Oliver. I've given you a tour of its main functions. I've showed you how to put on some key layers. I've also shown you a few features of GIS that you might be interested in, including how to get metadata, how to zoom in and out. What we didn't do was we didn't print from here, but you know what I'm going to do? I'm going to save that and see if we have questions about that in class. And the in-class questions might have to wait till Thursday. But I wanted you to have some hands-on work to do so you're continuing to explore things. And let me stop the video there.